All right, for this question, it says a load of 50 kilograms is raised a vertical distance of 15 meters, and that happens in 125 seconds by a motor. So we're first going to figure out what is the power required for this, and then we'll look at the efficiency and a few different situations. So for our initial setup, if this is our engine, and we're going to pull up an object which has a mass of 50. It's going to raise 15 meters, and the time that takes is going to be 125 seconds. So looking at this situation, we have the force of gravity downwards, we'd have a tension force upwards, and in this case, I would say it's going to move at a constant velocity, more than likely. And so then that's going to tell us that these two forces would be equal. All right, so what we can see is that I can find a velocity that it's going to move, or an average velocity at least, with this distance and this time. And we can use that to find power. So find power. Power is going to be force times the velocity. So one, we have to find velocity, which is simply my displacement divided by my time, which is going to be 15 meters divided by 125 seconds. And that's going to give me 0.12 meters per second. And then the second part is understanding what is my force. So because the tension force and my force of gravity would be the same, I could then say that the force is going to equal that force of gravity, right? So F is going to equal really the force of gravity, which is mass times gravity, which is going to be 50 times 10. So my force is going to be 500. So then the power that would be required would then simply be 500 newtons times my velocity of 0.12, and that is going to be 60 watts. All right, so for the second part, B, it says find efficiency. And basically what we see is that the engine itself, so the work in is going to be 80 watts, or the power in would be 80 watts. The power out is going to be 60 watts. And so my efficiency is going to be how much out over how much in. So that's 60 divided by 80, or an efficiency of about 75% efficient. So I'm losing about a quarter of my power somewhere, whether it's being lost due to friction or at some point, but within this, I'm only getting out 75% of the power that's actually being put in. So C says if the same motor is now used to raise a load of 100 kilograms with the efficiency remains the same, how long would that take? So for part C, again, find time for 100 kilogram mass. So essentially our power is going to equal 60 watts. Our force would be 1,000 newtons, and then we need to find time. So my distance is still going to be 15 meters, and I'm trying to figure out my time. So looking at that, power is force times velocity. We can rewrite that as force times displacement divided by time. And so I'm going to get time by itself, multiply each side by time, and then we're going to get power times time equals force times displacement, divide each side by power, and we're going to get that the time it's going to take is going to equal the force times the displacement divided by my power, which would be 1,000 newtons, 15 meters, divided by a power of 60 watts. And that's going to give me a time of 250 seconds that it would take that to lift. So if we think about, how that compares to what we had initially, for a 50 kilogram mass, it took a time of 125 seconds. And now for a 100 kilogram mass, we're doubling the weight we have to lift. So it should make sense that a time of 250 seconds would fit within that, because we're doubling the time because we have to double the weight.